A world-class observatory spent 17 years chasing signals from deep space that never should have existed. Papers were published. Theories were proposed. Astronomers around the world believed they were watching evidence of a violent, unknown process somewhere in the universe. In the entire time, the source was sitting less than 100 feet away in a staff kitchen. It began in 1998 at Parkes Observatory, one of the most respected radio astronomy facilities on Earth. A giant dish, 210 feet wide, scanning the sky for faint radio emissions arriving from unimaginably distant parts of the cosmos. Every day, the telescope quietly listened to the universe. Then something impossible appeared. Without warning, the system recorded a sharp millisecond burst of radio energy. It was brief, violent, powerful enough to stand out instantly against normal background noise. The kind of signal associated with catastrophic astrophysical events happening billions of light years away. The observatory had seen something strange, and immediately that mattered. Because radio bursts this short usually come from extreme environments, collapsing stars, magnetars, violent cosmic collisions, objects releasing enormous energy in tiny fractions of time. If the Parkes telescope had captured one, then astronomers might have discovered an entirely new kind of astrophysical phenomenon. At first, nobody questioned the detection. Why would they? Parkes had world-class instrumentation. Its calibration systems were trusted. The telescope had decades of scientific credibility behind it. The signal looked authentic. The measurement systems behaved normally. Everything appeared stable. Then it happened again. Another millisecond burst. Then another. And another. Over time, researchers cataloged more than a dozen of these bizarre events. They became known as Perytons, named after a mythical creature because no known object in physics seemed capable of producing what they were seeing. The strange part was not just the signal. It was the pattern hiding underneath it. Every burst looked remarkably similar. Same frequency structure, same duration, same sharp intensity spike. On paper, the evidence looked consistent enough to justify serious investigation. The frequency spike timeline became the center of attention. Researchers overlaid wave signatures, arrival times, signal intensity curves. Every graph pointed toward one conclusion. Something out there was transmitting. And Parkes had found it first. That should have been the breakthrough. Instead, it became the beginning of a very slow failure. Because astronomers outside Parkes started noticing something uncomfortable. No other observatory was seeing the same phenomenon. Not at Arecibo Observatory, not at facilities in Europe, not anywhere else monitoring similar radio frequencies. Only Parkes. At first, scientists defended the anomaly. Maybe the telescope geometry was unique. Maybe the sky position was unusually favorable. Maybe other observatories simply missed the narrow detection windows. It was plausible, until one detail refused to fit. Every single mysterious burst happened during daylight hours, not once at night. That was a problem. Cosmic radio signals do not care what time lunch starts in Australia. Now peer reviewers became skeptical. Published observations were suddenly under pressure. The scientific community began asking whether Parkes data was contaminated by local interference. But engineers checked everything. Receiver systems looked normal. Signal processing chains showed no obvious fault. Instrument calibration remained perfect. Nothing inside the telescope appeared broken. So the signals stayed in the archive, and the papers kept accumulating. Years passed. Then more than a decade passed. 17 years of unexplained detections. By now, the frequency spike timeline had become something much bigger than an isolated anomaly. Parkes' data helped shape discussions about fast radio bursts, one of modern astronomy's most exciting areas of research. Entire scientific models were being built around mysterious millisecond events. And hidden somewhere inside that process, an invisible dependency was quietly poisoning the data. Then, in 2015, engineers decided to investigate differently. Instead of looking deeper into space, they looked closer to home. Special radio interference monitors were installed around the observatory grounds. The goal was simple: catch local contamination in real time. For days, nothing unusual happened. Then suddenly the monitor exploded with activity. A sharp signal, identical to the Perytons. For the first time, the observatory had captured the anomaly while simultaneously tracking local interference. Now the source had to be nearby. Researchers started retracing everything happening on site when the burst occurred. Computers, power systems, communication equipment, maintenance operations. Then one pattern emerged. The timestamps matched staff lunch schedules almost perfectly. That frequency spike timeline returned again. But now the image looked completely different. Every mysterious cosmic burst had appeared at the exact moment staff members were heating food. Scientists moved toward the observatory kitchen. Inside sat an ordinary microwave oven. The final test was simple. Turn the microwave on while the telescope was operating. Nothing happened. Then they tried something else. Open the microwave door before the heating cycle finished. Instantly, the detector registered the exact same radio burst. The signal. The infamous Peryton. The mysterious deep space anomaly. It was never coming from space at all. The microwave emitted a tiny burst of radio leakage the moment the door was forced open mid-cycle. The telescope, sensitive enough to detect signals from billions of light-years away, captured it perfectly. For 17 years, astronomers had unknowingly been detecting their own lunch. And suddenly the consequence became much larger than embarrassment. Thousands of archived observations now had to be questioned. Signal verification procedures across radio astronomy required rethinking. Scientists were forced to confront a terrifying operational truth. The instruments had never failed. The theories had never failed. The trusted system itself had a hidden dependency no one could see. Because sometimes the most dangerous contamination does not come from broken machines. It comes from ordinary systems everyone stopped noticing. That frequency spike timeline never changed. Only its meaning did. The universe was innocent. The microwave was not.